live in an age defined by speed. With just the tap of a finger, we can summon a car, order food to our door, or even communicate with someone halfway across the world. Our phones have gotten faster, our internet speeds continue to soar, and even our expectations have accelerated higher and higher. However, this led me to question why the flight time from London to New York has increased. How is it possible that whilst everything else races ahead, crossing the Atlantic today takes longer than it did 50 years ago? Our answer lies in the engineering and retirement of one of aviation's boldest innovations, the Concorde. For those who are unaware, the Concorde was an engineering project developed and operated by a partnership between the British Aircraft Corporation and Aerospatiale. It is the world's only supersonic commercial jet and cruised at a top speed of Mach 2.04. For reference, the speed of sound is Mach 1, with the system operating as a ratio relative to it, so the Concorde flew at over twice this. In more recognizable units, it flew at a top speed of 2,180 kilometers per hour, whereas a typical commercial airplane nowadays would cruise at a top speed of around 900 kilometers per hour, or Mach 0.85. This speed meant that it was able to cross the Atlantic in under 3.5 hours, compared to today's 7 to 8 hours. It entered service in 1976 and was retired in 2003, and was comprised of a fleet of 14 planes. So, here we have an airplane from the 1970s that was able to take a flight time from today and halve it. How was it able to fly so fast? And in a world where saving time seems to be an art form, why was it ever retired? Let's start with the first question. In terms of engineering, the Concorde was artfully spun to maximize speed. It had 4 Rolls-Royce engines, which gave it enough power to rocket to the speeds it was famous for. It also had a very slim fuselage, which is the main body of the plane, and a delta wing shape, where delta references the Greek letter, which is triangular like the wing. This meant that it had a very aerodynamic design, so it was able to provide the necessary lift without requiring flaps. However, it did mean that it had a very high angle of attack when landing. To compensate for this, engineers developed arguably the most iconic feature of the Concorde's design, which was its famous droop nose, which could tilt downwards up to 12.5 degrees. This allowed for both optimal aerodynamics during flight and improved visibility during takeoff and landing. Cruising at an altitude of 18,300 meters also reduced drag, as well as less air resistance, as there were less available air particles to collide with. Flying at such speeds also meant that certain accommodations had to be made because of the extreme conditions. For example, the outside body of a plane could reach temperatures of up to 127 degrees Celsius during flight, and could expand by up to 25 centimeters because of the high levels of drag. This meant that high-grade aluminium alloys had to be used, as they were both light and able to withstand the necessary temperatures. It also had special sliding components and expansion joints to account for the change in size, and special reflective paint in order to compensate for the extra heat. And these were only some of the design elements that made the Concorde able to reach supersonic levels. But if it was so effective, then why was it ever retired? Our answer lies in a range of different factors, from passenger demands to the effects of sonic boom to maintenance costs. The most famously tragic of these was a rise in safety concerns after the 2000 crash. On the 25th of July 2000, Air France Flight 4509 crashed shortly after takeoff, killing all 109 passengers on board and 4 people on the ground. The crash was a result of a piece of debris on the runway left by another aircraft, which punctured the Concorde's tire. Rubber fragments from the tire then ruptured the fuel tank, resulting in a fire and engine failure. Although modifications were made after the accident, the devastating outcome from one mistake meant that public confidence in Concorde significantly decreased. This also coincided with a decline in demand for aviation as a whole industry due to the September 11 terrorist attacks of 2001, which saw a steep drop in passenger numbers, especially for premium international travel. However, though these 2 tragic events greatly diminished demand for the Concorde, it had been in decline even before then, starting with its energy consumption. The Concorde burned far more fuel per passenger than the average commercial jet. It consumed approximately 25,000 liters of fuel per hour, which was extremely costly, especially after the 1970s oil crisis. This then meant that ticket prices had to be exceptionally high in order to turn a profit, with customers paying costs of up to $12,000. The other reason why it burned so much fuel per passenger was due to its low passenger capacity, as it only carried 128 passengers, which is far fewer than the typical transatlantic flight. This then resulted in demanding passengers, who had paid such a high cost, so expected the best service, especially with the way the Concorde was marketed as a business-focused and exclusive aircraft. For example, there always had to be a spare Concorde grounded in New York in case of issues from a flight over. So at least one plane sat, making no money. However, it wasn't just this that bent the plane. The effects of sonic boom and pollution also gave cause for concern. When an object travels at a supersonic speed, it generates a continuous shockwave known as a sonic boom, with a plane flying at an altitude of 15 kilometers affecting a diameter of 80 kilometers below it on the ground. In the 1960s, the American Air Force ran a series of tests over Oklahoma City, with residents reporting hundreds of broken windows and noise complaints, limiting flights the Concorde could make to over oceans. It also burned more carbon dioxide per passenger than the typical transatlantic flight, creating concern as environmental awareness grew, with exhaust gases that could be far more damaging to the ozone layer than typical commercial airplanes. However, it wasn't just this that gave cause for concern. The Concorde was costly even when it wasn't in the air due to its maintenance costs. Due to the limited production of models, spare parts were scarce, and the required custom-built components became increasingly expensive over time. The final nail in the coffin was when Airbus, originally Aerospatiale, decided to no longer support or maintain the plane, citing cost and complexity, landing the Concorde for good. The Concorde was an extraordinary feat of engineering that brought supersonic travel into commercial aviation. In less than 75 years since the Wright brothers first took flight, passengers were crossing the Atlantic at twice the speed of sound. Yet, whilst its speed remained unmatched, the Concorde failed to evolve. As aviation technology advanced, newer aircrafts prioritized minimizing material cost and environmental damage. In the end, the Concorde stood as both a marvel of its time, but also as a reminder that innovation without adaptability cannot sustain progress. Thank you.